Then we have the Kalibr, first revealed to the world in 2012. Launched from ships and submarines, this missile has a range of up to 2,500 kilometers. The Kalibr family proved its power during real combat operations, striking targets with deadly accuracy. Weighing nearly 1.8 tons and measuring just over 6 meters, it quickly became one of Russia's most versatile and feared naval weapons. For many observers, Kalibr was a wake-up call that Russia's missile technology had entered a new era.
Now, the Oniks, Russia's supersonic sea-skimming cruise missile, officially introduced in 2002, it was designed to destroy enemy warships. With a range of about 600 kilometers and speeds reaching Mach 2.5, the Oniks is extremely difficult to intercept. At 8.6 meters long and weighing nearly 3 tons, it strikes like a spear from the sea, making it one of the most dangerous anti-ship weapons in service today.
Let's start with the Kh-55. This Soviet-era cruise missile entered service back in 1983, and it completely changed strategic aviation. With a range of up to 2,500 kilometers, it allowed bombers to strike deep into enemy territory without ever leaving friendly airspace. At 6 meters long and weighing around 1.5 tons, the Kh-55 was compact, reliable, and terrifyingly effective for its time. Even today, modified versions of this missile are still in use, proving how advanced it really was for the 1980s.
Next is the Kh-101, a modern heavyweight of Russia's long-range arsenal. Introduced in 2012, this missile has a staggering range of 5,500 kilometers. It's longer, heavier, and far more advanced than the Kh-55, with stealth features designed to evade modern air defenses. At nearly 7.5 meters and over 2 tons, the Kh-101 isn't just a missile, it's a precision strike system capable of carrying both conventional and nuclear warheads. This is Russia's answer to long-range global reach.
Finally, the Tsirkon, Russia's hypersonic cruise missile. Officially entering service in 2022, it's one of the fastest weapons on the planet, reportedly reaching speeds of Mach 8. With a range of around 1,000 kilometers, it can strike targets before most defense systems even detect it. At 8.5 meters and about 3.5 tons, Tsirkon represents the future of missile warfare, combining speed, stealth, and unstoppable kinetic energy.
The Kalibr missile family has its roots in 2 Cold War projects. The 3M-10 strategic nuclear cruise missile developed by Novator Design Bureau between 1975 and 1984, and the Alpha competition for new anti-ship missiles, OKR Biryuza. Initially, the supersonic P-800 Yakont was the frontrunner, but its development proved costly and slow. Meanwhile, the 3M-10 program faced uncertainty due to the looming Intermediate-Range Nuclear Forces INF Treaty. In 1986, Novator proposed a non-nuclear naval cruise missile known as the KS-122, but the Commission rejected it over its subsonic attack speed. Work, however, continued. By 1990, engineers had created an advanced version equipped with a supersonic terminal booster designed to punch through enemy air defenses. The collapse of the Soviet Union, however, delayed the system's deployment. Parallel efforts focused on an anti-submarine version of the missile meant to replace bulky legacy systems like Vodopod and Rostro-B. The first prototype of this type appeared in 1997. The Kalibr family made its public debut at the MAX 93 air show. By 2019, the system had become a core part of the Russian Navy's strike capability. According to open sources, the subsonic 3M-14 land attack cruise missile can reach up to 2,000 kilometers. The Kalibr NK version is deployed on surface ships. The Kalibr PL is fitted to submarines. The system is carried by modern platforms such as Admiral Gorshkov-class frigates, Project 223050, Buyan M corvettes, Project 21631, Yasin-class nuclear submarines, Project 885, and diesel-electric submarines of Projects 877 and 636.3, among others. In January 2018, reports surfaced about a new generation, the Kalibr M. This upgraded missile, funded by Russia's Ministry of Defense, is designed with a range exceeding 4,500 kilometers and a warhead of nearly 1 metric ton. Unlike the standard Kalibr, it will be significantly larger and is expected to arm larger surface combatants and nuclear-powered submarines. According to defense sources, the missile will be capable of carrying either conventional or nuclear warheads, with the primary role of striking strategic land targets. On February 5, 2019, Defense Minister Sergei Shoigu announced the start of work on a ground-based version of the Kalibr, to be developed in 2019 following the collapse of the INF Treaty. Today, the Kalibr system is seen not only as a symbol of Russian precision strike capability, but also as a flexible platform, one that can be launched from virtually any naval asset, with a growing range of land-based adaptations on the horizon.
Development of this new generation cruise missile began in the late 1980s, with full-scale design work kicking off in 1995. By August 2003, it reached initial operational readiness, and in 2012 it officially entered service. Unlike earlier Soviet-era missiles, which often relied on components from across the former USSR, this missile was built entirely with Russian-made parts. It introduced a modern guidance system that combined inertial navigation with electro-optical correction, and in the final stage of flight, it switched to an active seeker head for pinpoint accuracy. The missile could receive updated target coordinates mid-flight, something previous generations were unable to do, allowing it to engage not only fixed installations, but also moving targets. In its transport configuration, the missile's wings and tail surfaces are folded against the fuselage, while the R95TM300 turbofan engine is stowed inside. After launch, the engine deploys from the missile's body and the control surfaces unfold into a low wing layout. Testing showed impressive precision, a circular error probable of just 7 meters at a range of 5,500 kilometers, and the ability to strike moving targets with accuracy within 10 meters. These capabilities made it one of the most advanced long-range cruise missiles of its era, blending reach, flexibility, and surgical precision in a way unmatched by its predecessors. The P-800 Oniks, NATO reporting name SSN-26 Strabile, is a Soviet-designed supersonic multi-purpose medium-range cruise missile developed to strike naval task forces, individual warships, and even coastal infrastructure, all under conditions of heavy fire and electronic countermeasures. Work on this fourth-generation anti-ship system began in the late 1970s at the Central Design Bureau of Machine Building, CK BMS. Unlike earlier Soviet missiles, which were typically optimized for specific platforms, the Oniks was conceived from the start as a universal weapon. It could be deployed from submarines, surface ships, fast attack craft, aircraft, and land-based coastal defense systems. The missile uses a conventional aerodynamic design. A solid fuel booster sits inside the combustion chamber of the ramjet engine, igniting at launch. Once expanded, it is jettisoned by the incoming airflow, leaving the ramjet to power the missile through the rest of its flight.
Technical highlights: 3M55 Oniks. Length 8 meters ship-launched, 6.1 meters air-launched. Diameter 0.67 meters. Wingspan 1.7 meters. Launch weight 3,000 kilograms, 3,900 kilograms in canister. Speed Mach 2.0 at sea level, Mach 2.6, approximately 3,180 kilometers per hour at high altitude. Range 300 kilometers Oniks Yahond up to 800 kilometers Oniks Maximus. Flight altitude up to 14 kilometers in cruise, descending to just 10 to 15 meters near the target. Warhead 200-300 kilograms high explosive. Guidance inertial plus radio altimeter for mid-course in the terminal phase and all-weather monopulse active-passive radar seeker with frequency hopping plus minus 45 degrees scan angle and high resistance to jamming. Detection range at least 50 kilometers in active mode. CEP accuracy high with autonomous fire and forget capability. Readiness time under 2 minutes. Key features: over-the-horizon strike capability, supersonic speed throughout flight, reducing interception chances by enemy air defenses, flexible trajectories, low or high-low profile, universal compatibility with ships, submarines, coastal launchers and aircraft, high survivability in electronic warfare environments. Although the Oniks has not been used in real combat against warships, Russian Navy exercises have repeatedly demonstrated its ability to penetrate modern air defenses. Its sheer speed, exceeding 2,400 km per hour at low altitude, makes interception with surface-to-air missiles extremely difficult.
Back in 1971, Soviet engineers at the Raduga Design Bureau came up with an ambitious idea: a small, low-flying cruise missile with a nuclear warhead that could strike targets thousands of kilometers away. At first, the proposal was rejected, but just 5 years later, in 1976, the Soviet government urgently ordered the development of such a weapon. The result would become one of the USSR's most important strategic missiles, the Kh-55. The first prototypes, nicknamed Product 120, were built in Dubna in 1978. Soon, however, production shifted to the Kharkov Aviation Plant, KAHAP, which eventually took over full-scale manufacturing. Remarkably, the Soviet Union ordered mass production even before testing was complete. By December 1980, the first Kh-55 rolled off the line in Kharkov. It was designed to be carried by the new Tu-160 Blackjack bomber as well as the upgraded Tu-95 MS Bear. The first test launch followed in February 1981, and despite one minor failure, the missile quickly proved itself reliable. By 1983, bomber crews in Semipalatinsk were already training with live launches, and on December 31, 1983, the Kh-55 officially entered service. Tests showed it could fly an impressive 2,500 kilometers while hugging the terrain at low altitude to avoid radar detection. In the late 1980s, production was transferred to the Skirov plant, today known as Avitech, and supported by the Smolensk Aviation Plant. The Kh-55 went on to become a cornerstone of the Soviet Union's strategic bomber fleet and remains one of the most iconic Cold War cruise missiles ever built.
When it comes to design, the Kh-55 cruise missile was built using a conventional aerodynamic layout. Its body was a thin-walled welded shell made of aluminium-magnesium alloy, with most of the internal space occupied by a fuel tank. The wings, tail and nose cone were made of advanced composite materials. Before launch, the stabilizer and wings were folded, springing open with the help of explosive charges only after the missile was ejected from its launcher. At the heart of the missile was the R-95-300 turbojet engine, developed by MPO Soyuz and manufactured at the Zaporozhye engine plant. Originally, designers planned to use the TRDD-50 engine, but after extensive testing, the R-95-300 became the standard. Compact but powerful, it produced 300 to 350 kilograms of thrust, measured only 850 millimeters in length
and weighed just 95 kilograms. Remarkably, it delivered a thrust-to-weight ratio on par with engines used in modern fighter aircraft. Before launch, the engine was tucked inside the fuselage, mounted on a special pylon. As the missile deployed, the pylon dropped down from the tail section and the engine spun up using a pyrotechnic starter. The KH-55 ran on a highly toxic synthetic fuel known as desalinant-10, developed specifically for this missile. Unlike conventional jet fuels, 1010 allowed the engine to reach full power, but because of its extreme fluidity, engineers had to design an exceptionally leak-proof fuel system. Kharkiv Aviation Plant perfected this technology, while other factories struggled to replicate it. The R-95-300 engine also powered an onboard 4 kW electrical generator, which supplied energy to the missile's navigation and guidance systems throughout its long flights, something standard batteries couldn't achieve. For guidance, the missile carried an autonomous inertial navigation system paired with terrain contour matching. Before launch, operators uploaded a digital map of the terrain. During flight, the missile's onboard computer continuously compared altitude readings and landmarks with the stored map, adjusting its course as needed. The system enabled the KH-55 to fly extremely low, hugging the Earth's surface to avoid radar detection and to strike with impressive precision, achieving a circular aeroprobable CEP of under 100 meters. The missile carried a specially designed compact nuclear warhead with yield between 200 and 500 kilotons. Combined with its accuracy, even a single strike could devastate hardened strategic targets. Because of the missile's relatively fragile fuselage, it was suspended on bomber launchers using 4 attachment points. Despite its delicate structure, the KH-55 proved to be a deadly and reliable component of the Soviet Union's long-range nuclear arsenal.
One of the defining features of the 3M-22 Tsirkon missile is its extraordinary speed, reaching up to Mach 9, far surpassing not only other Russian anti-ship missiles, but also any comparable systems currently fielded by other nations. On February 20, 2019, Russian President Vladimir Putin announced in his annual address to the Federal Assembly that Tsirkon was capable of flying at around Mach 9 over a distance of more than 1,000 kilometers, and that it could be used against both naval and land-based targets. He also emphasized that the missile could be launched from surface ships and submarines already equipped with the Kalibr missile system. During flight, Tsirkon cruises at an altitude of 30 to 40 kilometers, where thinner air reduces drag, allowing it to maintain both higher speed and extended range. Its primary targets include enemy surface warships, from frigates to aircraft carriers, as well as key land-based military installations. With speeds reaching over 11,000 kilometers per hour, the missile presents a major challenge for interception, pushing existing missile defense systems to their limits. While not impossible to intercept, defeating Tsirkon requires faster reaction times and advanced technology. Current missile defense systems such as THAAD, Arrow 2-3, SM-3, SM-6, GBI, PAMS, SOMP-T with Asta-30, and Patriot PAC-3 are technically capable of engaging hypersonic targets, though the task remains highly complex. It should be noted that Tsirkon achieves its peak speed at high altitude and during sustained engine operation on the mid-course phase. In the terminal phase, as the missile descends and air resistance increases, its speed decreases, making interception somewhat easier. Concept images of the missile first appeared around 2016, presented by the Tactical Missiles Corporation and NPO Maszynostrojenia. According to available information, Tsirkon can be launched from the same UKSK vertical launchers that fire the P-800 Oniks and Kalibr 3M400EC cruise missiles.
However, it was later clarified that only the 6th Yasen-class Project 858 submarine would be the first to carry Tsirkon as standard, with earlier submarines requiring modifications to their 3S-14 launchers to accommodate the new missile.